Doubts? Reverse law only. Okay. So so if you know the prime factorization, you can easily consider one more than the power. So let us consider 48 as well. Instead of doing like this, you can take any one of these. For example, 3 into 16, right? So 3 power 1 into 2 power 4. 3 power 1 has how many factors? 2 factors. 3 power 0, 3 power 1, right? Similarly, 2 power 4 has how many factors? 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. 4 factors. So combination 2 power 4 has 1, 2, 3, 4, 5, right? So 5 factors. That is simply 4 plus 1, 1 plus 1. 2 into 5, 10 factors. Right? Let us consider 100. 100 can be expressed as 4 into 25, right? By the way, if you observe carefully, 4 is not a prime number. 25 also is not a prime number, but 4 and 25 are co-primes. That means they don't have any factor in common apart from 1. No factor in common except 1. So except 1 there is no common factor. So such numbers are called as co-primes, or they are also called as relative primes. Relative primes. So one shortcut is express a number as product of co-primes. So one shortcut is express a number as co-prime 1 into co-prime 2. Okay, which will be very easy for you to factorize. Okay, so 4 is 2 power 2, 25 is 5 power 2. So 2 power 2 has how many factors? 3 factors, right? 5 power 2 has how many factors? 3 factors. So 9 factors. Which one you get? Similarly, 121, it is 11 square. So 11 square has 3 factors. Straightforward answer. Okay, 120. 120 can be expressed as 5 into 24. 5 power 1. 24 can be expressed as 3 power 1 into 8 power 1. 3 into 8. So that is 5 power 1 into 3 power 1 into 2 power 3. Okay, 5 power 1 into 3 power 1 into 2 power 3. So you can consider 5 power 1 has how many factors? 2 factors. 3 power 1 has how many factors? 2 factors. 2 power 3 has how many factors? 4 factors. Combination of these two with these two with these two. 16 factors. So if a number is expressed as prime number 1 power a, into prime number 2 power b into prime number 3 power c, so on. Then sum of factors, it is equal to a plus 1 into b plus 1 into c plus 1, so on. Okay. This is not sum of factors, this is number of factors. Number of factors. Number of factors of the number n. Let us consider sum of factors. Sum of factors. So, you want to know what is the sum of factors of 120. Sum of factors of 120. Which is very simple. Add all the 16 factors. Add all the 16 factors. That is method number 1. Method number 1. There is one more way in which you can do. Now you know the prime factorization, that is 2 power 3 into 3 power 1 into 5 power 1. Right? We will start with a small number 6. 6 is equal to 2 power 1 into 3 power 1, right? We will start with this small example, then we can generalize that. So what are the factors of 6? 1, 2, 3, 6. Sum is 12. Right? Okay, so let us consider that here. 2 power 0, 2 power 1, 3 power 0, 3 power 1. Right? Combinations. What are the combination? 2 power 0 into 3 power 0 plus 2 power 0 into 3 power 1 plus 2 power 1 into 3 power 0 plus 2 power 1 into 3 power 1. These are the sum of factors, right? Each combination you get one factor. With each combination you get one factor. Sum of all this you get sum of factors, right? Sum of factors. Now this, if you can generalize, how you can do that? 2 power 0 plus 2 power 1 into 3 power 0 plus 3 power 1. 2 power 0 into 3 power 0, 2 power 0 into 3 power 1, 2 power 1 into 3 power 0, 2 power 1 into 3 power 1. Right? So that we can generalize here. So from this you want to get the sum of factors of 120. How do you get that? 2 power 0, 2 power 1. Basically there are some factors of this. What are the factors of 2 power 3? 2 power 0 plus 2 power 1 plus 2 power 2 plus 2 power 3. Combination into 3 power 0 plus 3 power 1 into 5 power 0 plus 5 power 1. If you do this multiplication, you will get the answer. Okay? So if a number is expressed as p1 power a plus p2 power b plus p3 power c, so on, into, right? Basically I am talking about prime factors, where p1, p2, where p1, p2, p3 are prime numbers. Prime numbers. Then sum of factors of n, it is equal to p1 power 0 plus p1 power 1 till p1 power a into p2 power 0 plus p2 power 1 till p2 power b into p3 power 0 plus p3 power 1 plus p3 power 2 till p3 power b, so on. This is the formula. Please take down fast. Okay, let us take a small problem. Find the number of factors of 390. Try this problem. Okay. Number of factors of 390. Let us first prime factors 390. 13 into 3, 39. So 13 into 30. Right? So this can be further done as 3 into 2 into 5. So 390 can be prime factorized as 13 power 1 into 3 power 1 into 2 power 1 into 5 power 1. So number of factors 13 power 1, 2 factors, 3 power 1, 2 factors, 2 power 1, 2 factors, 5 power 1, 2 factors. So it has 16 factors. Okay. We'll make this a bit more interesting. How many of them are odd? How many of them are even? How many of them are, try this. Okay. Now how many of them are prime? You have got this 16 number through prime factorization as such, right? So how many of them are prime? Only these are the prime numbers. Any other combination will give you a composite number, right? So the answer for this is 4. 2, 3, 5, 13. Next, how many of them are odd? A number which is not divisible by 2 is an odd number, right? So it should not have combination of 2 power 1, right? That is very simple. 13 power 1 has combinations 13 power 0, 13 power 1, right? Factors. With that 3 power 1, 3 power 0, 3 power 1. You should not have 2 power 1, otherwise it will become even number. So you should consider only 2 power 0. With this you consider the combination of 5 power 0, 5 power 1. You will get odd numbers. That is 2 into 2 into 1 into 2. 8 factors are odd. Applying the same logic, 13 power 0, 13 power 1. With this 3 power 0, 3 power 1, with this combination. 2 power 1, 5 power 0, 5 power 1. Any power of 2 except 0 will give you an even number, right? Here you have only 1. If you have, let us say, 2 power 2 also, so then in that case 2 power 1, 2 power 2 you will get, right? So here 2 into 2 into 1 into 2, that is 8 factors are even. Please take them fast. Consider as well sum of factors. Sum of factors of 390. Thirteen power 0 plus 13 power 1 into 3 power 0 plus 3 power 1 into 2 power 0 plus 2 power 1 into 5 power 0 plus 5 power 1. So in this case it is 14 into 4 into 3 into 6. You can get the answer. Okay. Let us take one more problem. A number is expressed as 2 power 1 into 3 power 2 into 4 power 3 into 5 power 4. Find the number of its factors. Try this problem. Okay, question is very easy, but some of you might have done this kind of mistake. That is, 2 power 1 has 2 factors, 3 power 2 has 3 factors, 4 power 3 has 4 factors, 5 power 4 has 5 factors. 23 is a 60, 62 is a 120. This is wrong. Why? Because this is not prime factorization. I have told that it has to be P1 power A into P2 power B into P3 power C, so on, where P1, P2, P3 are primes. Here 4 is not a prime. That is blunder number 1. Otherwise the problem is very easy. So you have to convert it to prime factorization. So if you convert to prime factorization, 4 power 3 it is equal to 2 power 6, right? So 2 power 1 into 4 power 3 it is 2 power 7. So the number is 2 power 7 into 3 power 2 into 5 power 4. So this number has how many factors? 8 into 3 into 5, right? 15 into 8, 10 into 8. Luckily you got the same answer, even if you did mistake like this, but it usually do not happen, right? Question answer is right, but the approach is wrong, right? 8 is 24, 24 5 is 120 factors. This is the correct approach. Next, find the digit in the units place. Find the digit in the units place of 360 power 24. Try this problem. Okay. 360 power 2 if you consider. What is that? 360 into 360, right? Forget about what is the answer, but the last digit is supposed to be 0, right? So, using the same logic, 360 power 24, irrespective of what is the number, the last digit will be 0, right? So, a number that ends with 0, consider any power to it, I'm talking about natural number. So, a number that ends with 0, power n, it will have last digit as 0, right? Next. Using the same logic. What do you understand? A number that ends with 1 raised to the power of n, where n is a natural number, it will have last digit as 1. Similarly, a number that ends with 6 raised to the power of n, it will have last digit as 6. Okay? Next. Try this problem. So one thing is common, it just depends on the last digit. If you want to know the last digit, it just depends on the last digit of the number, which is raised to the power. So 4 power 1, 4, 4 power 2, 16, last digit. 4 power 3, 64, 4 power 4, 64 into 4, that is 16 into 16. Number that ends with 6. Right? You don't need to worry, 256 is the number. But the last digit is what I am bothered about. So, here 154 power 35. 35. It depends on what is the power. If the power is even, last digit is 6. If the power is odd, it is the same number. So what do you understand? A1, I'll consider A2. A number that ends with 4 power even number. Even natural, odd natural, even natural. You'll get 6. Similarly, a number that ends with 9, power odd natural number, you'll get 9. A number that ends with 9 raised to the power of even natural number, it will be 1. Next, by the way, you can add one more thing here, 4, that is a number that ends with 5 raised to the power of any natural number, it will give you 5, right? Okay, so 0 is done, 0, 1, 5, 4, 6, 9, these are done. So what is left out? Left out ones are 2, 3, 8, 7. If you can frame logic for these, you can frame logic for these also, 2, 3, 8, 7, right? But let us not involve in making logic for these. Let us use the understandings and then try out. For example, if you want to find last digit of 432 power 256, similarly 183 power 74, 138 power 52, likewise 257 power 38. Try this. Okay. Let us consider 432 power 256. So it is as good as considering 2 power 256, right? So 2 power 256. Why not take help of 4? 2 square is 4, right? So 2 power 256 I can write as 4 power half of this, 128, right? Four power 128. Now 4 power 128, 4 power even number, which implies last digit is 6. Okay. Next, 183 power 74. For change, let us consider 75, right? One 183 power 75 will consider 3 power 75, right? Why not take help of 9? Because 3 square is 9. But then this is not divisible by 2. So 3 power 74 into 3, right? What is 3 power 74? 9 power 37 into 3 power 1. 9 power 37. 9 power odd natural number is 9. 3 power 1. So 9 to 3, 27. So last date is 7. One 38 power 52. It is as good as 8 power 52. 8 square 64. 64 power 26. 4 power 26. 4 power even 6. Next, 257 power 38. Seven square is 49. So 257 power 38 is as good as 7 power 38. To find out last digit, 7 power 38 we can consider 49 power 19, right? For 49 power 19 it is as good as 9 power 19. 9 power odd will give you 9. Please take down fast. Okay. Let us consider next category, highest power of. Find the highest power of 2, 3, 5, 10. For all these, it's the same question. In 100 factorial. Try this problem. Okay, before doing this, let us take one small example in understanding. Let us consider 10 factorial. 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. Now if you want to find highest power of 2, what are the powers of 2? Here also you have 2, right? How many you got? 1, 2, 3, 4, 5. One more way in which you can understand. 10 by 2 is 5, right? But then that is not enough. I have just considered multiples of 2. What I am talking about is, suppose you consider 4, right? So here I am considering 2, 4, 6, 8, 10. I am just considering it as just one multiple. Suppose you consider 4, 8. They are not just two multiples. They are 4 multiples or powers of, they are multiples of 4. So I would consider 10 by 4, which is 2, right? Just consider quotient. 2 factors, right? So one more thing that you have missed out here. 8 is not just power of 4, it is also power of 8. So it is 2 cube, right? So if you consider 8, you have one more 2. So what is the power of 2? Power of 2 is 8. What I am trying to do is 2 into 4 into 6 into 8 into 10, right? From this I can take out 2. So how many you got? 1, 2, 3, 4, 5. 2 power 5, right? Now similarly 2 power 5 into, here also you have 2, 4. I am taking out 2, 2. I have one more 2 here. So 2 power 5 into 2 power 2 into 2 power 1 into 1 into 1 into 3 into 5. So these are all 2 powers, which I am expressing as 2 power 8 into some number. It is equal to 10 factorial. Therefore highest power of 2 is 8. Okay. Using the same logic, try doing this for 100 factorial. Highest power of 2, highest power of 3, highest power of 5, highest power of 10. Let us take a small break.